If you go inside the same petroleum expert, you're going to see this gap software then.
Okay.
Inside the same file in a drive C, you see this gap software, which is what we'll use principally today and tomorrow.
Okay.
Hope you can see my screen.
Yes, I can see it.
Now, we may have a situation where in a particular field, we have different wells in that particular field. We know that generally, we always connect our well to the wellhead, and then from the wellhead, we have a flow line to the separator. But if we have more than one well in that particular area, and these wells are producing, instead of connecting each well to the separator, they may now find a way of connecting all these wells together so that they flow together to the separator. So all of this is what we call surface networking. So what we are going to do in GAP is to try to see how to simulate this particular situation, because if these two wells, A1 and A2, are connected, then we expect that the mass flow rate into this point, which we may call it a node, it should be the same as the mass flow rate out of the point. So what the software is doing now is trying to solve this particular concept, physical concept, to find an equilibrium condition where all of them can coexist together, and then we have a single flow line condition. So this is to tell us that if we have a particular change in any well, we expect a change also in the flow line condition. If we have a change in the flow line condition, it will definitely affect this pressure at the node, which in some cases it may be the wellhead pressure. And once the wellhead pressure is affected, the entire system is affected. So a change in the flow line or in the pipeline system will affect what happens in our individual well, and a change also in the individual well will affect the entire system. Because if I have an increase in gas oil ratio in, let's say, well A1, I expect that there should be a general increase in gas oil ratio also in this pipe, in this particular pipe. So as a result of that, there is a change in the operating condition. The pressure at this node will be different, the pressure at this node will be different, and definitely is going to affect the pressure also at the separator. So we are trying now to look at how we can model this particular situation. And if we have to model this particular situation, there are a lot of things that have to come in. Okay, there are a lot of things that have to come in, because we need to do an analysis of this system, which we call nodal analysis or system performance. We have to also analyze this system and also analyze all of these. So Prosper has to come in one way or the other in order to do the system analysis. We may also have a situation where this particular well, let's say A1, is receiving hydrocarbon from two different horizons, two different layers. So we may talk of interlayer or multi-layer. So in this particular case, we will now have to connect this AY to A1 to two reservoirs, to two different reservoirs. So this A1, which is a well, is receiving hydrocarbon from two different reservoirs. So what I have here is just a general concept of what we may expect. So this node position, which is at this position here, it could be at the wellhead or it could be at the manifold. So if in your Prosper software, you include this little part, which is a little flow path before the manifold, then our gap system is going to connect this particular point, but to the manifold. It means that this particular well ends at the manifold, then the next well also comes up and also enters into this manifold. So this manifold now is going to be this junction. But if in our Prosper software, we have not included this manifold, which is what we have done in most cases, we have not included this manifold, then the connection now will be at the wellhead. So it means that there is some kind of a connection between the two wells at the wellhead, which principally will be very difficult because the wells may be at some distance apart. So definitely we may have some kind of a connection. So in that case, to model it, we have to include this part also in our Prosper software. But for now, we are going to keep it easy and model the system in our Prosper to end at the X mastery or at the wellhead. All right, so this is just our general situation of a single well that is connected to our separator. We have generally our reservoir performance, our wellbore performance, which form our system analysis. This is our wellhead. This is our wellhead where we have our wellhead pressure. And then our manifold is somewhere along the line, which we have not yet indicated there. So all of this is just a recall of what we have done. So what we were supposed to have done in Prosper is to save some models that we can use in GAP. But since we did not save those models, we will just quickly, before we come to GAP, we will just quickly go to GAP and produce about three different well systems so that it can give us exactly what we have here as our A1, A2, and B1. Because we have this system, we need the nodal analysis of that system. So I'll just quickly go to GAP, to Prosper, before I come back to GAP. So let me see this. Okay, so this is the data. I'm going to input this. This is the data that we have to produce the 3 wells. So I will start. We have all of this. We'll just leave this as default. I've already explained most of these things. Okay. It takes time for the systems to work. So we come back here, we have to put all of this. So our gas oil ratio is 500, gravity is 30, gas gravity is 0.7, our salinity is 100,000. That's our salinity, 100,000. All right, so all of this, if we have our PVT data, we could also match. So we may go to match data. I think I have a data here. So I'll copy this and yeah, it's not pasting. I think, did we succeed to paste? Oh, yeah, I think we did. Oh, not yet. Cancel. So much. All right. All right. So our temperature is 200 and our bubble point is 200. Our bubble point is 3070. So we are going to match. All right. So this is our match data. I showed how to look at the parameter in order to be done. All right, match all. All right, so this is our parameter now. From here, we have to decide which one is the best, but by default, all right, we have chosen this. It's already showing us the match result. All right, so we have our PVT data, which is match. We'll just quickly, we don't want to waste time on this because we have already done all of this. We come now to our IPR. I have the data for that. Reservoir pressure, we have 4,000. Temperature 250. Water cut 25. Gas oil ratio, we already have that. Our IPR, we'll go to Vogel. We put our test point, let's say 250 at the bottom, hole flowing pressure of 2,000. 2,000. All right, so we calculate and then we plot. And that's our IPR. All right, we don't want to waste time on this because we have all of this already. Now we go now to our system. We are going to work with deviation. We work with deviation. Want to take on this. So we take this downhole equipment, yes, geothermal gradient, and average heat. So I take exit, it starts from there. So I think I have a data already for our deviation, measure depth and true vertical depth. I will copy that, paste. All right, this one is done. Done. I go now to my downhole equipment. We have our Exmos tree, starts with Exmos tree. The next one, we have tubing. Here we just call it tubing. I'm not going to give any explanation here because I've already given all of this. So at the depth of 2,000, the inner size is 2.9. There we have tubing gauge. Right down to 6,000. So we have two tubings. We have a bigger one and a smaller one. And then after that, we have casing. We'll just call this casing. And then we'll just write down to 8,000. All right, I think that's a depth. And then the size is 6.18. 6.18. All right, so we are done with that. Then for our temperature at the surface, we have a temperature of 60. At the depth of 8,000, we have a temperature of 250. So done. Oh, the rate of heat transfer, let's just say 8. Done. All right. That's done. So if I reduce this and I take the summary, so we have all of the summary of what we have inputted. So this is done. I can enlarge this back. Okay, I go now to calculation, system, calculation for IPR and the VLP. I click on that. We have our water cut already. We have our total gas oil ratio. The pressure at the node, let's say 300. The pressure at the wellhead pressure. Okay, we calculate and show result. All right. So we have done the calculation. You see that for the results, we have our liquid rate oil rate, water cut, how it varies. We have our gas rate. We have the pressure of the vertical lift performance, the change in pressure in the system, and the change in pressure in the IPR also, and all of that. And then we also have wellhead pressure, which is constant. We have our wellhead temperature, and then we have change in pressure due to friction, so many other things, which we have already explained. So what we will do now is we have already set up our IPR. So what we'll do now is we are going to save it. So we'll go to save, we'll save this. All right, we'll just call it A1. We'll just say, well, A1. We'll just call this as well A1. And then I will just choose where to save it. Desktop. Let's put it under GeoSavers. That's week 9. All right, well, A1. Okay, I'm going to save it there. All right, so I'll come back now and probably just do some few adjustments, and then I will call it now, well, A2. But, well, A2 may have its own property. So let's just say this water cut is 15. Let's say this temperature is 220. All right, I'll calculate. So I want to form well models for 3 wells. So at this level, anyway, let's just leave the same property. I've just changed that. So let's leave the same property. I will come to calculate again. System. All right, I'll recalculate now. Our node now, let's say 250. Let's say our wellhead node in this case is 250. All right. Show result. All right, it has been calculated. Done. Save as. So I'll save this now as A2. I'll save this one now as A2. Save. Our A1 is there. I may still come back to the system and then change. This one now could be well B1. Okay, this temperature could be, let's say 2, and then the water cut could be 10, and then the gas oil ratio also, let's say 450. I will calculate this. Done. Then I come now to my system performance. I will change this to 200, wellhead pressure to 200. I think we change this to 10. And this is 450. 450. All right. Oh, did I even calculate? Cancel. All right, calculate, show result. All right. So done. I will call this well B1. Well B1. All right. So I have my 3 wells which I want to use in my gap to do my surface modeling. I'm already done with this. Things. So no need again. All right, so this is my gap system now. So what I want to do now in this our gap system is to model this particular case. I want to do a modeling of this particular case where we have 3 wells, A1, A2, and A3 that are connected at the surface to a single separator. So A1 and A2 have a common node. I've already explained that this common node could be at the manifold or it could be at the wellhead. But since in our Prosper software, we did not include anything about this manifold, we ended here. It means that the 2 wells will be connected at this point. They'll have a single wellhead pressure. where they are connected to. So we want to build this system and do our simulation in GAP. So what we are going to do now is we will start the building. We start with a new, we start with our GAP, we start with new. All right. The first thing there is to go to option and look at method, and they will now bring us a table that we have to fill. What is our system type? What do we have there? We have a production, we have water injection, we have gas injection, and then we have the gas lift injection. Gas lift injection is a situation that we applied for artificial lifts to lift up the hydrocarbon from the system if it is not functioning properly. And we realize that what is causing that system not to function properly is the vertical lift performance. That means the performance of the well bore. Then we may now bring in an artificial lift method. But in this case, we are going to leave it as our production. Now, what do you want to optimize? There are different things that you may want to optimize. Optimize means you're trying to simulate to bring out the best appropriate value, the best value that is suited for the entire system put together. So you may want to optimize the revenue, how much revenue you may have for that particular system. You may want to optimize the oil rate. If I take, for example, the revenue, if I take, okay, if I come back to here, I might look at exit revenue regimes. So when I take a revenue regime, there are some pre-questions that have been asked that I have to input, that the system will now look at all of the tax regime and try to see how they can bring out the maximum revenue that you can obtain from that project. So this could be another line of research that you're doing. If you're writing your final thesis, maybe at the undergraduate level, you want to use GAP, you may want to optimize your revenue. So what we'll do now is you have to give the revenue from oil. How much is the price of oil per stop tank barrel in dollars? You may change the unit if you want. You may change the currency if you want. You have the revenue from the sales of gas, the cost of water processing. Remember that as you're bringing the hydrocarbon from the subsurface, there's water there, you have to process the water. The cost of gas lifts, if there's a gas lift system, the cost of power, the energy that is needed to drive the system, the cost of power fluid, the cost of diluents, cost of steam. So there are so many other things that you have to bring in. You may have different tax regime for the different wells. All the wells must not have the same tax regime. They may have different tax regime. So if you want to do that, you can always add. You can always, if you want to change the currency, this is where you change the currency. You can always add another tax regime, about 2 or 3 of them. But once you go now into optimization process, you have to choose now which tax regime is working now for which well. So we'll just leave it at this level. Then we go back to our method, we look at other things. We have our PVT model, which I've already explained several times. It could be black oil model, it could be compositional model. And if you're taking compositional model, it could be tracking or fully compositional. All right. So we want to do you want to do prediction also? Do you want to predict what the pressure will be, what the temperature will be, and all of that? So we want to do this prediction. Then we have our wax and hydrate warning here, which is off. Then we have our water vapor. How do you want to do the calculation? So we are saying no calculation that. You could also use calculation for that to calculate the condensed water vapor and all of that. Our temperature model, remember when we started GAP, the first session on GAP, I took time to explain this prediction of pressure and temperature. If you're taking pressure and temperature, it means that you don't know what the temperature will be. But if you know the temperature of the system, you can just take only pressure. Once you take pressure only, you realize that this heat transfer coefficient automatically goes off. So, but what we are going to do, we are going to take pressure and temperature. Okay. And then what is the method of estimating the temperature? We have three methods, which I explained already under Prosper. We have rough approximation and improved approximation. Here we have just two, but in Prosper, we have about three of them. We have heat transfer coefficient. You have to enter the heat transfer coefficient. Will you be the one to enter it, or you want the system to calculate it? So the other option is allow heat transfer coefficient calculation, but we'll leave it at enter it. And then what is the brine properties? What's the property of the water? Can you input it, or you want to use correlations? Water viscosity, you want to use correlation and all of that. So we'll take okay. Now, the next thing is to build up this system, the well system that are connected to this separator. That's the next thing. So we'll come here to our separator. We'll take this separator, we click on it. Once we come here, you click anywhere, they'll ask you, what do you want to input? Our production separator. That's what we want to input. We'll take yes. The name will just be separator 1, but you could give another name. We'll click OK. Now, you realize that it is at the node that the system is doing that operation, that regression analysis, where it is solving all these complex physical problems in order to give the best operating condition. So it is at this node that the system is trying to do that operation. So we need to input these various nodes at the various points. If you have some wells that are connected to a single node, you can now include them at the end of the day. So this separator also has a separator pressure and temperature condition. It also has nodes. So what I will do is I will take, this is a node. I will just put it there close to the separator. That's a node of the separator. They'll call it J1. I will leave it like that. I will come now to the next thing, which is a pipe or a link. So there's a big difference between a pipe or a link. This and this is considered as a pipe, but these two, they are not considered, 1, 2, 3, are not considered as pipes. They are considered as link, just a link between these two systems to this particular node. So I will take this as a link. I want to link this node to the separator. This particular one is the node of the separator, where we can simulate the pressure at the separator and all of that. Okay. The next thing now is for us to indicate our wells. So I will take this, I'll add our well there. I will just call this well B1. I'll just call that well B1. I take OK. I will put another one here. I'll call it well A1. I'll take OK. I click here also. I'll call it well A2. And I'll take OK. We also have to put the well heads of these various wells. So we come to our add join. We click on it. I click beside here. It's just going to give us a name J2. Since one was J1, we'll just leave it like that as J2. I will click, since these two are linked together, it means that they have a common wellhead. They have a common node. So I will click here and I'll just call that J3. So I'll come now to my add link and pipe. I click on it and I connect these two. I connect this one to this, and I also connect it to this system. All right, and I connect this one to that system. All right, so you are looking at the direction. You realize that it is actually telling us that the mass is going to flow from this well towards this particular point. Okay, after we have now included the nodes, we might now link these two. Remember, we are still at add link and pipe. Once I am linking these two, the system is no longer seeing it as a link. It is seeing it as a pipe. That's why you have these two symbols there and this little symbol at the beginning. The system is now seeing it as a pipe. I can now link these two also. And the system is now seeing it as a pipe. You now realize that our separator now is highlighted, which means that there's some kind of a connection that links flow from different systems into that particular separator. There are so many things that you can do. I can go to view, I go to icon size, I increase the size of the icon, I increase the size of the icon if I want to see it well. If I want to be seeing things well, I can increase the size. And I take OK. This is our system. If you want to remove something, there's something here like a scissors. Once you go with your mouse there, it indicates that you have to, maybe it's delete. You want to delete something. I may come, take the zip. If I want to remove this pipe, I click. All right, once I click on it, you realize what is happening. It has gone. And what is happening now is that this one now is no longer highlighted because there is no link. There's no link where the hydrocarbon is going to go. So if I come back to pipe and I link it, you realize that the system is going to be reactivated back. All right. This does not mean that at any given point in time, all of these wells must be operating. Maybe one well, one or two wells will start production with one or two wells before along a given period of time, you may have other wells that are added together. So if I bring my mouse here, I have mask. If I take this mouse and I click here, this particular well is masked. It means that it is not going to be included in my simulation. It's not going to be included in my simulation. This mask is different from another way of just cutting it off, because this masking simply means that I can mask it for 2 months, and then after 2 months, it starts operating. But if I want to remove the mask, I'll come here and I click here, it is unmasked. Okay, here now is disabled. When I click here and I click on this, that one now is totally disabled. That means you cannot activate it at any given point in time. So that's the difference between masking and disabling. You can mask a system and you can also disable a particular system. So when I disable the system, I cannot activate it at any given point in time. But when I mask it, I can tell the software that activate this particular well after 2 months. So immediately it is doing the simulation. After 2 months, this well A1 automatically becomes activated. So I'll click on it and I'll enable it. I've bet my system, but I don't know exactly what is flowing in that system. So what I will do now is I can just double click on any of them. Once I double click on any of them, this page now is open. I have now where I have to input what exactly is found in each of those wells. I have my B1, A1, and A2. I can always change any of them. I can always change any of them. Now, when I get into this system now, let's start with A1. Now they're asking, the first thing is what type of well. We have already given a name label, well, A1. If there's a special name, you can give a special name. If there's any comment, you can write down the comment. What type of oil is found? What type of fluid is found in that particular well? It could be oil. It could be, there are so many other things. It could be gas, a producer. It could be a gas producer. It could still be an injector. It could still be an injector. But in this case, we have our oil producer. All right. How do we want to model the system? How do because in order for us to actually know the mass flow rate in this particular system, we need to know how the reservoir is functioning, and we need to know how the wellbore is functioning, which gives us now what we call our nodal analysis. So in this case, we are just going to take we are going to take VLP plus IPR. If I take outflow performance only, which means that I want to, in this particular case, I have only my vertical lift performance. If I take all of that, let's see what is happening with the system. You realize that this system now is circled, which means that it is not active because there is nothing that is connected to it. Here we have a well ball performance, but we don't know what the reservoir is and how the reservoir is performing. So I can still come here and add my reservoir, but we don't want to complicate it. We want a situation where we have our well performance and our reservoir performance. All right. The next step now is to input our Prosper file. Our Prosper file that we have just developed, we have to input it here. So I will browse. I will go to desktop and I look at where I kept the file. That's the file, well, A1 there. I will click on it and I'll take open and it shows that it is valid. I can also take run Prosper down here. Once I take run Prosper down there, I look at it. The Prosper is going to open to give us exactly what we built in Prosper. You can look at it. If there's any adjustment that you want to do, you may want to do those adjustments. But it's exactly what we built in Prosper. All right. Now, here they're asking us now our tax regime. Which tax regime do we want to use? So if we have built different tax regime, we may want to use this if what we want to optimize is our revenue, if the basis of our optimization is our revenue. But what I'll just cancel this first. I will go back to option and I will take optimization. Let's optimize the oil rate only. Let's optimize the oil rate. I'll come back there. You realize that that option is no longer active. That option is no longer active. Okay, seems like I didn't save that file. No issue, I'll input it back. All right. What if we don't have our Prosper software or we don't have our Prosper, our analysis that we have done in Prosper? There are different ways in which you may do that analysis. I may come here to IPR, you realize that it is invalid. It is invalid here. Even our VLP is invalid. I will click on it. So there are various ways in which you can input that. If you have all of this information for your IPR, you can input. If you have different layers, I may come to add layers and I have about 2 or 3 layers within that same well. That's what we call a multi-layer analysis. Most of these aspects, most of these aspects I've already taken time out to explain it. But you realize that for our IPR model here, we have just a Vogel, the straight line and Vogel. Remember, before the bubble point, it is a straight line. And after the bubble point, it now starts curving because we have gas that is now operating in the system. So how does this GAP software now works with all the models? Because we have different models in our Prosper, but here they are talking only of straight line and Vogel in that particular case. So what the software will do is now they'll go to the IPR that you have developed for whichever model that you want to develop. They will pick about 2 or 3 points on this particular curve. Then they'll recalculate the productivity index of that system. Then they will use that productivity index and then they will now work with it as if it is a Vogel equation. So that is how the system now will calculate all of it. So if I don't have my Prosper model, I may have my productivity index, the layer pressure, the layer temperature, the permeability, compaction, correlation. Remember that generally there is what we call the isothermal compressibility. This isothermal compressibility simply tells us that as you're drawing the hydrocarbon from the reservoir, the drop in pressure within the reservoir also affects the pore spaces. So as you're drawing, the pressure is reducing, the pore spaces are also compressing. Why are these pore spaces compressing? Because the grains are expanding. The grains of the sandstone or whatever we have there are expanding due to that drop in pressure. As the grains are expanding, they are squeezing the pore spaces. So as production is going, we don't expect the permeability to be the same. The permeability is dropping. So we may have that permeability compaction correlation. Okay, we have cross flow also. If we have a multi-layer, we may have a situation where fluid is moving from one zone and entering into the other layer. So that's what we mean by cross flow. So we have to input all of these parameters. We have to do this only if we don't have our Prosper model. I'll go back to summary. For the VLP, the same thing. If you don't have your Prosper model, you come there and then you have to start working with that VLP file. You have to give a name for it because it is difficult for you to generate that VLP. Remember, even when we're doing Excel, we could generate IPR with our Excel, but VLP was very difficult. So in this case, I have inputted the file for A1. I will do the same for A2. I will do the same for A2. I will input the file for A2. I will do the same for B1. I will include the file for B1 then. All right. So I will take now, okay. Remember our IPR and the VLP are still in red. They are not yet reading this Prosper file that we have inputted. They are not yet reading it. So we'll take okay. We will come now and tick on this. We'll take this arrow that we have here and we take this. We want to generate, we want to work on it. We want to do some simulation with these 3 wells. So we'll tick the 3 wells. We will come to generate. We'll click on generate. They'll ask us what we want to generate. The first one there is generate well IPRs with Prosper. So I will tick on that. And then I will highlight all the wells that I want to generate. If you want to generate for all of them, fine. If you want to generate for only 1 or 2 of them, you can still do that. So I'll click on generate. All right, it will work and it will tell us that IPR generate finish. So I will take okay. If I come back to my system, you realize that our IPR is now okay. Our IPR is now okay. If I go now to the IPR, you see that the system, it has already filled all of these, the productivity index, the temperature, and all of that. It has already filled all of this. If I have some constraints, I may also add some constraint. Maybe I have some abandonment constraint that at this particular gas oil ratio, you can abandon that well. It means that the system will stop simulating for that particular well or will cut that particular well out of the system immediately any of these constraints is reached. I may have a minimum gas oil ratio. I may say maybe at a minimum gas oil ratio of 40 standard cubic feet per stock tank barrel, that particular well will be abandoned. So you may have some abandonment constraint. You may have to include that in it. But here it's okay. Remember, our VLP is still the same, showing red, not valid. So I will come back to generate. I will now take generate this. All right, so it will give me well by well. So I have this generate for gap model or for simulator. So you may have to generate what you want to generate it for. Do you want to generate probably we have some model that we just want to keep somewhere or we want to use it for simulation. We can take simulation. Then they now tell you simulator, petroleum experts that are just telling you exactly where the simulation will be saved and all of that. All right. So what we will do is we have done a lot. So I want you now to probably take your time and go through it. Take your time and go through it and develop all those models, A1, A2, and A3, so that you input it into the system of GAP, so that tomorrow we can now run the GAP simulation and see what is happening with the operating system and what is going to be our optimal oil rate at the end of the day when all of these systems are connected. So I may just go to file and I will take save. Or ask me where they want to save this. I'll go to desktop, Josephus Summer Internship week 9, and I may just put there the one. I'll just put there the one, and I'll save it so that tomorrow we can easily open it at this point, so that we will not need to go and restart everything back afresh tomorrow. So we have saved this. All right, we can now close it. All right, so I expect you to go through it